Hi everyone, welcome to join us in the Low Temperature Thermochronology online lectures. In this chapter 2, I'm going to introduce you some basic concepts in the low temperature thermochronology. I'm Nitao from School of Earth Science and Resources, Chang'an University. This QR code here will direct you to my university homepage, where you will be able to find more information about this course. In section 1, we went through some key terms in geochronology and radiometric dating. Here comes an interesting question. When does a chronometer start to measure? To answer this, understanding of an important concept, closure temperature, is critical. In physical terms, the closure temperature is the temperature at which a system has cooled so that there is no longer any significant diffusion of the parent or daughter isotopes out of the system and into the external environment. The concept of initial mathematic formulation was presented in a paper by Martin Dodson in 1973, where closure temperature was defined the temperature of a thermochronological system at the time corresponding to its apparent age. This concept is quite useful, as we can thus relate a mirror age to a temperature in the Earth. The closure temperature of a system can be experimentally determined in the lab by artificially resetting sample minerals using a high-temperature furnace. As the mineral cools, the crystal structure begins to form, and the diffusion of isotopes slows. At a certain temperature, the crystal structure has formed sufficiently to prevent diffusion of isotopes. This temperature here is what is known as closure temperature and represents the temperature below which the mineral is a closed system to measurable diffusion of isotopes. The age that can be calculated by radiometric dating is thus the time at which the mineral cooled to block temperature, since the geological clock is on. Closure temperature, however, vary broadly as a function of the thermochronological system, mineral size, chemical composition, and cooling rate. This definition also only works when cooling is monotonic, or no reheating. When the mineral experiences reheating from temperatures lower than blocking temperature, the upper temperature limit of fully closed system behavior to that exceed the open system temperature, which is defined as the temperature that corresponds to the lower limit of the fully open system. The diffusion of isotopes reinitiates. The mineral turns to an open system, where the geological clock is therefore reset. Closure temperatures are used in geochronology and thermochronology to date events and determine rates of process in geological past. The above is section 2 of chapter 2. Thank you. Next section is thermochronology basics.